All right, welcome to Unit 3, Unit 3's CRT preparation. What we are going to be covering in this topic is we are going to be covering these weighted averages, so weighted average, and then the general topic of average, variance, sample standard deviation, and coefficient of variation. All right, so let's begin with weighted averages. You can see that right here, this is the formula for a weighted average. So to kind of better understand what this is saying is, this is the sum of Wx divided by the sum of W. This only applies to categories in which there is both X and W, where X is like the score that you have and W is the weight. So example right here, Sally is preparing, this is terribly written, is preparing and concerned about her statistics grade. All right, so completed categories would involve these assignments, these tests, but notice how this would not include the final. Again, because it's only for categories that have both the X and the W. So again, these are the scores and these are the weights. So this is the X and the W. So the weighted average is Sally's grade. So real quickly, how you can do this is, what is Sally's current grade? So what we can do is we can go to our calculator here, and the top would be the weights multiplied by the scores added up. So the weights times the scores added up. So in this numerator, the weighted average is going to be equal to, Sally's grade is going to be equal to, the top is the weight, which is going to be 10%, times her score, which is 83%. Okay, so that's the first W times X. Now the summation is going to be an addition of all of the W times X's. So the next one is the tests. So, oops, let me try that one more time. I accidentally hit a bad button here. So we have the assignments, W times X, plus the tests, W times X. Okay, so the numerator is 0.447. Let's see if I can write this. All right, so that is the numerator, 0.447. The denominator is going to be, so the denominator is going to be just the summation of the involved W's. So the W's are the weights, so that would be the summation of all the W's, so that's 10 and 70. Again, it does not involve that 20% final because it doesn't have a corresponding X. So that denominator is going to be 0.8. So when all said and done, this is going to be the weighted average, aka Sally's score, which is going to be 0.447 divided by 0.8. And we see that Sally will have a score of 0.5588. So not passing. Not passing is her. So she has a 50, almost a 56%. So she currently has an F without that final. All right. So I've left you with 3 problems to kind of work at and kind of investigate, look at. And if you have any questions, go ahead and make sure you post them under the attendance tab in the Google Classroom, or bring it up when we have our web meetings. All right, so, but this is, in general, the weighted average. Okay, moving on. average variance, sample standard deviation, coefficient variation. We have all of these formulas right here, and we have some problems to be looking at. All right, so my example is what is the mean, the variance, the sample standard deviation, the coefficient of variation of these two lists. Now, these are all fine and dandy, but my huge indicator to you is this. Get this answer and get this answer using your calculator's capabilities. So what I mean by that is this. We can go to our calculator. What I'm going to do is I'm going to set this up as a stats list. So I'll show you this this list A here. So list A is comprised of 0.25, 0.97, 0.03, 0.87, 0.11, 0.15, 0.89, and 0.91. All right, so we have 8 numbers in this list, and then what we can do is we can calc 1 var. All right, so if I calc 1 var, what I can see is that my x bar, right now I'll just write it as x, is equal to 0.5225. Okay, that's x bar. I can't write a bar on this. And right now I see that my S, okay, is this one right down here. It's this sigma n minus 1. On your other calculator, it would be the SX. This is the S right here, this number right here. And so I see that the S in this situation is 4195. So that is S. Okay. All right. So this is the sample standard deviation, and this is the mean. Okay, this is my X bar. Let's see if I can actually create one here real quick. Quick and dirty version. There's X bar. Booyah-cha. All right, so this is my mean, and this is my sample standard deviation. Now, the rest of them, you're just going to kind of have to get, but they're really easy. So, for instance, the variance. The variance is, as you can straight up see, is s squared. So you don't have to worry about the sum of x minus x bar, et cetera, et cetera, et cetera, because this is just straight up x squared, or s squared, excuse me, s squared. So what I can do is I can go to my calculator and menu 1. I can take my s, which is 4195, and I can square it. Thus, this is s squared. This is the variance of 0.1760. There's my variance. Coefficient of variation. Coefficient of variation, this last question right here, is just pretty much calculator work. It's pretty foolproof. So coefficient of variation is equal to S, which is 0.4195, divided by X bar, 5225, times 100. And so the coefficient of variation is 80.2871. All right. So we have all of these different values that we have created. And I'll do this for list B here in just 1 second. Let me real quickly kind of talk about what these things are. Average is, as you know it, it's the average. So it's the middle ground of all this stuff. It's on average, this is what it is. Variance, not that important. It's not used that very much. Standard deviation. This is a general spread between these numbers. Like for the distance, or not really, yeah, kind of like the distance between any of these random numbers is 0.4195. Now that number doesn't really make much difference. It doesn't really mean much, but yeah, so it means something, but really what this is going to be related to, the coefficient of variation, is like how big is this spread, 0.4195. 0.4195 is pretty big when you're talking about these types of numbers. It's like 80% of what the average is. But you know, you might get a standard deviation that is larger, but doesn't really necessarily mean that it's a larger spread. You'll see what I mean here when I create this second piece here. Let's see if I can do this. All right, so I am going to work with the second group, so I will just kind of show you kind of quickly what I do to get these answers using my calculator. All right, so what I did right there is I filled out all the same information, but again, what I'm kind of alluding to is this last question that's going to be asked. So relative to the size of the numbers in the list, okay, which one has a smaller spread? Oh, shoot, I made a mistake right here. I'm sorry, give me 1 second. There it is. All right, so what the coefficient of variation is the answer to this question. So this is a generic spread, and you might think, wow, 12, a spread of like 12 numbers is bigger than 0.4195. Well, you might think that, but you could be talking about two completely different things. Like, how far is the city of Phoenix from the city of New York? Wow, that's a really long distance. Well, how far is planet Earth from Mars? Well, in the realm, in relative terms, Earth is really close to Mars. Earth is really close to Mars, but Phoenix is not close to New York. So even though the number, the standard deviation of Earth to Mars would be incredibly larger than Phoenix to New York, how can you say, oh, Earth is close to Mars, but Phoenix is far from New York? Well, it's all relative. And that's what the coefficient of variation lets us know. And so what we see here is relative to the side, which has a smaller spread. List B has the smaller spread. B is smaller relative to the numbers that are currently there. So that's what that coefficient, that's what that coefficient of variation is describing. That's what the coefficient of variation is describing, is that right there. Okay. So here are some 4 problems for you to do. Now, I understand that some of you do not have this calculator. I'm working on the issue. I think you can download and use, what the heck? You can use this calculator when you are using your own personal computer. Like I'm running off of my personal Dell computer. I don't think it works very well when you're using like a Chromebook or something like that. I mean, I don't know if it works on a phone, but if you use it on your own personal computer, you should be able to do what you need to do. Okay, what was I saying though about these problems right here? How can I get these answers if I don't have this fancy schmancy calculator, but instead I have, you know, like my phone or something? And I created this. Okay, so to get the average, again, what you can do is you can add all these numbers up and divide by the number of numbers. So that's relatively easy. You don't need a fancy calculator to do that. So you add up all the numbers, you divide by 1, 2, 3, 4, 5. Boom, you got your X bar, which is 8. So X bar is now 8. Cool. Working towards the standard deviation, which is the variance, is actually the very first thing that we are going to be working towards. So what we need to do is we need to take X minus X bar. So X is the individual number, and then X bar is 8. So the first would be 5 minus 8. The next would be 12 minus 8. 7 minus 8. 10 minus 8. 6 minus 8. And so you can get these X, which is the list, minus X bar, your average. So X minus X bar. Oops, kind of jumped ahead there. Let me delete this row right here. Yeah. So you got X minus X bar. Okay. So what we're working towards is the sum of X, your list, minus X bar, the average, squared. Okay, and then this is going to be divided by n minus 1. Oh my God. All right, you get the idea. N minus 1. All right, so X minus X bar squared. So we have X minus X bar. Now we got to just square these. So -3 squared is +9. 4 squared, 16. -1, 1. 2, 4. -2, 4. So these numbers squared. Okay, X minus X bar. Let me just do one more thing. Clone page. All right. All right, so we have X minus X bar squared. Now all that's left is we have to sum X minus X bar squared. So 9 plus 16 plus 1 plus 4 plus 4, 34. And that is the sum of X minus X bar squared. Okay, so so the list of things that we have to solve for, what we have right now is we have X bar is equal to 8. What I'm working towards is S squared. And so what this is the sum of X minus X bar squared divided by n minus 1. So this is going to be 4. Okay, 8.5. Okay. S is just the square root. It's just the square root of S squared. So back to my calculator, what I can do is I can square root this answer, and that comes out to be 2.9155. And so we have X and the coefficient of variation. The coefficient of variation, which is S divided by X bar times 100, and ta-da, no fancy calculator necessary. 438. Again, I apologize for all the handwriting. It's very difficult just straight up using my calculator or my computer. Okay, so you can get this stuff done with no fancy schmancy calculator. You can just use these things. Do your best. There's this last question that you're supposed to put them in order. So again, just put them in order from coefficient of variation, small to big. That will be small to big of the relative spread. All right, hopefully this was helpful. And again, if you have any questions, please post them in the attendance section of in the check-in, or talk to me when we have our video conference. All right, have a good day, everybody. Keep smiling.